Hello friends, welcome back my YouTube channel MS Maths. In this video, we are going to discuss about a topic of fluid dynamics, that is the equation of continuity. In this lecture series, we have discussed the basics of the fluid that we have started with the definition of the fluid dynamics and then with some properties of fluid and streamlines, streak lines and basically path lines we have already discussed. Stream tube we have already discussed in our previous lecture, and some question based on the material derivative and streamline and stream tube we have already done. So in this case or in this lecture, we'll discuss a particular type, that is basically the equation of continuity within with the different type of coordinate system. So first of all, we should know about that. What is the coordinate system? Coordinate system is the representing the address of a point or the location of a point in a space is represented by the coordinate system. There are so many coordinate system like rectangular coordinate system, in which we will use a rectangle. It means x comma y, or basically it means it is x y z. In this case, we'll use a rectangle shape or rectangular coordinate to like locate a point. It's like next will be the cylindrical, in which we'll use the angle in that case, and we'll get the equation of continuity. There is also a spherical coordinate system, in which we'll use the angle and the coordinates or the axis with the z axis. So these are the types of basically these are the types of coordinate system. So first of all, we start with the rectangular coordinate system, the equation of continuity, and it is like very important topic, and it basically based on the conservation of mass. Okay, so in the rectangular coordinate system, let basically rho x y z t density of fluid at point P. I say point P is basically, this is our point P, and at any time t, the amount of fluid that passes through the PQRS. What is the PQRS? So I just want to denote all the points. That is basically, this is P, this is Q, R and S. This is a one of the rectangle in which the fluid passes, and in the same manner it is Q dash, R dash, P dash and S dash. So basically the length is basically del Z, del X and del Y. It means this is Y axis, this is Z axis, and I say this is X axis. The velocity component, basically Q vector is Q vector basically U I cap plus V j cap plus W k cap. So we can write it as in the component that U, V and W. So the W component within the Z direction, U component with the X direction, and this is basically V. Okay, in the same manner this direction is basically V. So it is velocity component. Velocity component. Now the fluid passes through the PQRS surface is basically rho V del X and del Z. I say this rho V del X del Z is nothing but function of X, Y, Z. This is basically the equation number 1. In this case, this rho denotes the density, this V is basically velocity, and del X and del Z is basically del X and del Z, basically the area. Now the amount of fluid that passes out through the surface P dash, Q dash, R dash and S dash is basically, we can like write as rho V del X del Z plus some del X, or like a dou by dou X is rho V del X del Z and del Y. This is basically the equation. because the change in the direction is basically along the x-axis, or like del x del z. This is basically the area change of amount in like basically particular direction. This represent the change of amount in particular direction. So now the net change is basically within the direction y a, like this is basically in the direction of x, and now we'll find the along y axis. So basically the in the direction of y, that is basically rho v del x del z minus rho v del x del z plus dou by dou y rho v del x del y. Okay, this is for particular del y direction. So now like minus dou by dou y of rho v, and that is del x del y and del z. Okay, so in the x direction, it is in the y direction, so we'll find within the x direction basically, that is minus del by del x rho v del x del y del z. Okay, in z direction we have minus dou by dou z, or basically we have here y, and dou by dou x is basically rho w del x del y and del z. So basically within the like three direction, the net change will define as dou by dou u, dou by dou x. Okay, here basically that is dou by dou y, and this is dou by dou z, sorry for that. Now yeah, in this case that dou by dou x is rho by rho into u minus dou by dou y rho v minus dou by dou z rho w, because in the x direction the velocity component is u, velocity component in y direction is v, and z direction is w. So we can write it as del x del y del z with the time some delta t. Now I say this is our equation number 1. So the rate of change of fluid inside the control volume per unit time. So this will basically dou by dou t, because we will calculate it per unit time. Dou by dou t rho delta x delta y delta z and delta t. This is I say equation number 2. By conservation of mass, so the mass conservation law, equation number 1 is equals to equation number 2 with the time the mass with the velocity is equal in the different direction, or different with the difference axis, that is basically x y z, and with the time that will be equal. So we will write that dou by dou t rho del x del y del z and del t will be equals to dou by dou x rho u minus dou by dou y rho v minus dou by dou z rho w is basically that is del x del y del z and del t. Here will be also del t. So this will get cancelled. So dou by dou t rho dou by dou t is equals to, because this will like wait, this is not in the derivative, okay, this term not in the derivative. So we can write it as this form. Okay, this is not in the derivative, so we can cancel. So basically, if I can write in this way that dou by dou x rho u plus dou by dou y rho v plus dou by dou z rho w is equals to 0. Equation of continuity in rectangular coordinate system. Then the equation of continuity in rectangular system or rectangular coordinate system is basically dou by dou t. It is nothing but plus del dot p into q vector, where q vector is not p, that is rho basically. Q vector is u v w. Rho is basically the density, and delta is nothing but dou by dou x I cap plus, or I can write it is an with the in the form of u I cap plus v j cap plus w k cap. Then it will be dou by dou y j cap, dou by dou z k cap. By the dot product, the I cap, j cap, k cap will be 1. Multiplication of these all are equal 1. With this some special case, like I say the case number 1, or in the special case, if fluid is incompressible, then the condition of incompressible is basically the density is constant. Whenever the density is constant, then dou by dou t is equals to 0. So basically this term will be 0. Okay, we can also write here rho. So dou by dou t is equals to 0, then rho dot q vector will with the dot product of del is equals to 0. It means that rho into del dot, not cross, del dot q vector is equals to 0. So we can write the divergence of q vector is equals to 0. It means the dou u by dou x plus dou v by dou y plus dou w by dou z is equals to 0. So this is the equation of continuity of incompressible fluid. It is very easy to calculate. Now for steady state, there is another concept or another case we can take as for steady state and compressible. So in this case, rho may change with respect to spatial coordinate. So basically with the space will get changed, then del cross rho into q vector is equals to 0. So this will be the condition for this. Okay, so this is the like these two are the equation. This is within the incompressible, this is within the compressible, and this is in general the equation of continuity. So this equation in the rectangular coordinate system. Now if we have a cylindrical coordinate system in which the velocity vector in cylindrical coordinate system is basically QR, Q theta and QZ. What is R and what is theta? So I say it is Y, it is Z, it is X. Then in the cylindrical coordinate system, like basically we have, wait, this angle is theta and this is del theta and this is R. So if I'm going to point out these points, is basically this is the surface. Okay, so the surface is basically slight the form of like this. This is P, Q, R and S. Basically it is P dash, this in this manner. So in the same thing we can make the angle with the del theta is basically this is the angle del theta. So this will be Q dash, P dash, S dash and R dash. These two are the surfaces and this length is basically del R. Okay, so here let us consider rho is the density, rho is the density. Then cylindrical, in the cylindrical coordinate system, if we calculate, the equation will be, I am not going to calculate performing the whole derivation, just to write, I am writing the equation, that is del rho by dou rho by dou t plus 1 by r dou by dou theta rho theta q theta plus 1 by r dou by dou r is basically r qr into rho plus dou by dou z rho into qz is equals to 0. So this is basically the equation of continuity in cylindrical coordinate system. There is also some case, that case number 1 for incompressible fluid. Basically rho or density will be the constant. It means del rho by del t is equals to 0. So the 1 upon r del by del r r qr plus del by del z qz plus 1 by r, that del by del theta q theta is equals to 0. And for the same spatial coordinate system, it means when the fluid is compressible, or we can find for that. So this is the equation of continuity for the incompressible fluid within the cylindrical coordinate system and the rectangular coordinate system. I hope you got this method, and to find the continuity equation we'll use further to solve the questions. So that's for watching my video. Keep watching MS Maths. Thank you. Bye bye.